Okay, Sentinel values and bubble sort. So Sentinel values and or transversal path terminators in programming are basically used as conditions of termination. So usually in loops or repeating algorithms. They don't hold or reference actual data that's in the data structure. So computation doesn't really encounter it as a legitimate processing unit. So in other words, a Sentinel value is chosen typically as data values that the loop won't meet and hence not encounter or interact with. So Sentinel values can be used once the number of repetitions for a looping process are unknown before the actual repetition structure begins. And also to signal the end of user input. Hence why algorithms which repeat until a Sentinel value is seen are known as Sentinel loops. They're also typically associated to file streams. So some common Sentinel values and their uses include null characters for indicating the end of a null terminated string, null pointers for indicating the end of a linked list or tree, as well as negative integers for indicating the end of a sequence of non-negative integers. So as an example, they can be used in programming where test scores are provided, and when a certain value is inputted, it could result in the termination of the loop and then lead to, say, the average being printed. So in that example, -1 is used as the Sentinel value because it's an algorithm which computates non-negative integers. And so such a value can be set as the SV because it will never encounter it as a legitimate processing unit. So this is basically that third example right there. Okay, bubble sort. So bubble sort is basically a comparison-based sorting algorithm that basically involves comparing and swapping adjacent elements if they're out of order. So if n elements are to be sorted, the process will basically repeat itself n-1 times until recognition. So out of all the other sorts, it is the most tedious and counterintuitive in comparison to, let's say, insertion sort, mostly because of its simplicity, so it is more counter-efficient. And the actual pseudocoding of the procedure. So one flag variable swap is used, which will help us see if any swap has actually occurred. If no swap has occurred, the array requires no more processing to be sorted, thus it will exit or come out of the loop. After every iteration of the highest value settles down at the end of the array. Hence, the next iteration need not include basically the already sorted elements. So for this purpose, the inner loop is restricted to avoid already sorted values. So basically, sometimes it could be the fastest sort available out there, but only for extremely small and or nearly sorted arrays. The algorithm is basically not suitable for large data sets as its average and worst case complexity will be about O times n squared, so where n is the number of items.